Hello. Let's just do a recap on quadratic equations that you guys have seen in grade 11. So when we talk about quadratic equations, you're already familiar that quadratic equations or quadratic functions, right? We are talking about something like this. Let me give you a plot. For instance, you've got the set of your x values, you've got the set of y values, and then let's say maybe a plot goes like that, right? Okay. Mainly, what I want to discuss with you basically it's how you can actually define your quadratic function, your equation from the basics, right? So let's say this is function f, right? And we do know that usually our quadratic equations, right, they are in the form y equals to ax squared plus bx plus c, right? So we're going to be talking about the definition of what each means, right, for what each term means or what each variable means, right? So from the basic equation, when you've got a quadratic equation or a parabolic graph, something like this, it is built on the x-axis. It is attached on the x-axis, right? So right where it's been attached, we call it roots, right? So these are roots. So this is root 1 and this is root 2. So for this function, you always have two roots. Right? So let's say this is x1 and this is x2. So these are called your roots, right? So the basic equation or the basic way to come up with an equation of a quadratic function, okay, you will do this if you are given roots, right? So this is how the basic equation starts from, right? I will say basic equation, right? So basic equation is generally given by y equals a into x minus x1 multiplied by x minus x2, where x1 and x2 are your roots, right? So after multiplying this out, right, and you know the value of a, let's say you know the factor of a, right? So this will actually produce the so-called your quadratic equation, which will be in the form y equals ax squared plus bx plus c, right? From which in this equation, the value of a basically tells you the direction of the graph, right? So the value of a tells you the direction of the graph, and the value of c, this is the y-intercept. This is the y-intercept. The value of c is the y-intercept, right? Okay, so for instance, let's talk about the value of a, right? So if the value of a is positive, let's say we talk about a greater than 0, so that's when your a is positive. When you talk about the direction, so your graph will be more or less like this, right? So it comes from the positive infinite and then it turns back to the positive infinite. As your x values increases, right, your y values also increases. As your x values increase, your y value also increase, right? So if your a, the value of a is less than 0 or is negative, so your graph would be sitting like this, right? So it's gonna come from negative infinite turns back to the negative infinite, right? So this is how it looks like, right? This is your x, and then that's your y, and that's your y, right? So this is when we talk about the basic function, the basic equation, right? All right. And then there is also another form of this equation, right? So there's also a form called, right? So you have seen in grade 11 that we actually shift from using this form, ax squared plus bx plus c, to a form called what? To a form called y equals a into x plus p squared plus q, right? In this instance, right? Let's talk about the values of P and Q. When you talk about the values of P, so the value of P means what? Means your horizontal shift, horizontal shift, right? And the value of Q here talks about what? The vertical shift. That's the value of Q. The value of Q is the horizontal vertical shift, right? So for instance, let's say we've got the graph here, right? Let's say we've got our graph, something like this, right? And then you've got, right, you can see that this graph is actually shifted from the origin, right, to turn up here. It turns here, right? Okay, so basically that becomes your P value and this becomes your Q value. So in this form, already you've got the coordinates of what? Of the turning point. So your turning point will be P and Q, right? And then let's talk about the domain and the range, right? So for instance, let's talk about the domain, right? Domain. So domain, we do know that domain is the set of x values of your graph for which your graph is defined. So your x values, right, will be an element of all real numbers. And we do know that your x values will be ranging between minus infinite to positive infinite. And then when you talk about the range, so the range, okay, we're talking about x values. Range, we're talking about y values, right? So in this instance, we do know that y is an element of what? Is an element of real numbers. But our y ranges from the minimum value, which will be the value of q here, right? Which is the value of q up to positive infinite. So that's when we talk about the range and the domain. Or you rather say your y value, or you can say your y value is greater or equal to the value of q, right? Remember, the value of q can be positive or negative depending on where your graph turns around, right? For example, let's say let's do an example, right? For example, right, so let's say you need to determine the equation of this following graph. You need to determine the equation of this graph here, right? What is this graph? So this graph is we are given roots and the turning point. Okay, we need to define this, and then we are given the roots, which is 3 and minus 2, and the turning point we are given as 1 and minus 8, right? And we need to determine the equation, right? So if you are given roots, remember we just discussed that you need to use the basic equation of quadratic formula, right? So you are basically multiplying x minus x1 and x minus x2, right? So what is x minus x1? So x minus x1 would be x minus negative 3, x minus 2, right? And when you multiply that out, when you multiply this out, your y will be a into x squared plus x minus 6, right? What do you do now to get the value of a? You're going to substitute by the third coordinate that is given in your equation, in your graph, of which in this case we've been given the turning point. So we will say here minus 8 equals a into, we substitute that coordinate here, and then this is going to be something like this. So when we calculate the value of a, we'll find that a is 2, right? So therefore we will say that y equals to 2x squared plus 2x minus 12, and there we've got our equation in the form ax squared plus b squared plus c, right? Not forgetting that this is x and this is y. And I hope this makes sense. Thank you.